Welcome, astute explorers. Today, we embark on a thrilling voyage to the stars, where we'll unravel the intriguing mysteries of optical satellite communication. Now, you might be wondering, what exactly is optical satellite communication? Well, let me enlighten you. Imagine you have a friend on the moon and you want to send them a message. But instead of using words, you decide to use a torchlight, flashing it on and off in a special pattern to convey your message. That, dear explorers, is the fundamental idea behind optical satellite communication, but instead of a torchlight, we use powerful lasers. And instead of your friend on the moon, we're communicating with high-tech satellites orbiting Earth. These lasers flash on and off, sending streams of light-coded information across the vast expanse of space, connecting us to the universe beyond. So, in essence, optical satellite communication is just like sending coded messages using torchlights, but on a space scale. Now that we understand what optical satellite communication is, let's delve into the mechanics of this fascinating process. Imagine you want to send a message to your friend across the room, but you can't make a sound. What do? You might consider using a flashlight to send a Morse code message, right? Well, optical satellite communication works on a similar principle, but on a far grander scale, and with much more complex messages. Here's how it works. The information we want to send is first converted into a digital format, basically a series of ones and zeros. These ones and zeros then get translated into light signals with the help of a laser. The laser light is then beamed into space towards a satellite. The satellite is equipped with a receiver which catches this light beam. The light beam is then converted back into digital data by the satellite. This data can then be sent back to Earth or relayed to other satellites. The beauty of this process is the speed and efficiency of light-based communication. Light travels at a staggering speed of 186,000 miles per second. So, even when we're sending data to a satellite hundreds or even thousands of miles away, it takes only a tiny fraction of a second for the data to reach its destination. But why use light? Well, light can carry a lot more data than radio waves, which are traditionally used for satellite communication. It's like comparing a two-lane road to a superhighway. Moreover, light signals are less likely to be interfered with by natural or man-made obstacles. This means that the data being transmitted is less likely to be lost or corrupted, ensuring a more reliable and efficient form of communication. Also, the equipment required to generate and receive light signals is much smaller and lighter than that used for radio communication. This makes launching satellites into space cheaper and more efficient. Through this incredible process, vast amounts of data travel at the speed of light, connecting us with the farthest reaches of our universe. You might be wondering, what's the practical use of this space-age communication? Well, let's explore some real-world applications. One of the most significant benefits of optical satellite communication is its ability to provide internet access in remote areas. Yes, even in places where traditional cable-based internet is a far-fetched dream, this technology is a beacon of hope. It's like having a digital superhighway connecting even the most isolated parts of the world, enabling people to access information and services that were previously out of reach. Now, let's consider a more urgent scenario: disasters. In times of calamities, when land-based communication networks are often disrupted, optical satellite communication can serve as a lifeline, facilitating crucial communication for rescue missions and relief operations. From the comfort of our homes to the furthest corners of Earth, optical satellite communication plays a crucial role in keeping us connected. Like every great invention, optical satellite communication also faces its share of challenges. But every problem presents an opportunity for innovation, right? Let's delve into some of the obstacles that stand in our path to stellar communication. The first one that comes to mind is atmospheric interference. Optical signals are susceptible to weather changes and can be disrupted by clouds, rain, or fog. This means that the quality and reliability of the communication may be compromised. Another hurdle is technological limitations. The equipment needed to receive and process optical signals is complex and expensive. This includes the telescopes, the detectors, and the laser transmitters. Moreover, precise alignment between the transmitting and receiving stations is crucial, which can be quite challenging given the vast distances involved. So how can we overcome these challenges? One potential solution is to develop adaptive optic systems. These systems can adjust the shape of the mirrors in the telescopes in real time to compensate for atmospheric turbulence. This could significantly improve the quality and reliability of the optical signals. In terms of technological limitations, ongoing research and development could lead to more efficient and cost-effective equipment. Breakthroughs in nanotechnology and quantum computing could revolutionize the field, making optical satellite communication more accessible and widespread. While there are hurdles to overcome, the future of optical satellite communication shines bright with endless possibilities. So, let's keep our eyes on the stars and continue to push the boundaries of what's possible. As our cosmic journey comes to an end, let's recap the amazing things we've learned about optical satellite communication. We've explored how light beams carry data through space and how they help us in everyday life, from providing internet access in remote areas to aiding communication during disasters. We've also touched on the challenges and potential advancements in this field. With that, we conclude our journey into the world of optical satellite communication. Remember, the next time you look up at the night sky, there's a lot more going on than meets the eye.